Hello, everyone. Good afternoon. Thank you for joining on time. Early birds. Feel free to settle in, and we will be starting in a couple of minutes. Good afternoon. Welcome. Thank you for joining us. We are starting in a minute. Okay. Well, welcome everyone to this joint session on digital tools as enablers of replication. Brought to you by WATERSENS, CARDIMED, AQUAMON, and NBRACER projects. For the purpose of dissemination, we will be recording this session and we'll disseminate it through our social channels. And a quick word on our how we are going to do this today. So as you could see, you're as attendees in a listen-only mode. No mic or camera needed until we have the interaction into place. So when we are going to do a Q&A session, we can use the sound and the image. And of course, feel free to use chat and Mentimeter for exchange of your ideas, thoughts. They're more than welcome. And use these to give us your questions or comments. If you have any technical issues, my colleague Nicole here. Nicole, can you give us a wave? Who can support you. We'll drop a message in the chat. You have her email. Okay. So today's focus is definitely on how digital decision support tools actually add value in projects like ours, maybe also in your projects, in your organizations. So when we use them in understanding the problem, assessing potential solutions, or maybe even in transferring knowledge to other sites. To be on the same page, okay, we put this very simple definition on decision support systems as a software tools that integrate our data, models, and analytics to help users, maybe when users like you, evaluate options and make informed decisions in complex situations. This is the definition we can keep in mind throughout today's session. Well, we are very happy and pleased to have today 4 speakers. from different projects that arrive from different moments in their project duration. So they are in different process of development of the tools, from ideation to some kind of testing. And so we have in the first place, we have Maximiliano Oportus Foster. He is a water resource engineer at CETAQUA Water Technology Center. He will be here representing CARDIMED project that works on NBS exploitation and transferability of support modules. And then Thomas Papas, an associate researcher at the Athena Research Center in Greece, presenting us here today how AQUAMON monitors urban water quality in real time across pilot sites. We'll also have with us Carolina Canterigiani, as a senior researcher in climate change adaptation at Tecnalia. And she'll represent NBRACER today and tell us a bit more on monitoring journey guide for regions as an 8-step guide for assessing the impact of nature-based solutions. Final not the least, our colleague and co-host of today's session, Jesus Fernandez Aguilla. He's an R&D engineer in water technology at the ITG Technology Center, leading the development of the WATERSENS decision support system tool for decentralized water management. As you can see, we're in good hands of these 4 projects, working on different digital tools. And today, definitely, they will help us to understand a bit better how these tools actually add value when solutions move between different sites. Before we go into understanding about these projects a bit deeper, let's try to do a bit of warm-up. So we invite you to join us on Menti. Menti, you can use either a QR code with your phone or the code itself through menti.com. My colleague will also drop a chat message with the direct link if it's easier for you. Feel free. I'll give you a moment and then I'll share the screen. Okay. So we have 20 people joined. Perfect. Let me just do one thing here. So we can see it together. Okay. Just give me a second. Sorry. With these heat technologies getting a bit slower. Apologies for that. Okay, here we are. I see 27 people joined. Amazing. So first things first, where are you joining from today? Can you give us a hint? Drop us a message of your place or a country, your region, neighborhood. Maybe we know that much geography, maybe we don't, but let's see. Whatever comes to your mind first. What do you feel as a local context? So great. We have Italy, Germany, Berlin, Germany again, Krakow from Poland, Greece, north of Spain, very good. Iraq, okay, very far, but still quite good geographic territory. Chile as well. Okay, so we have people who are here with us very early in the morning, the ones that are already celebrating the lunchtime, and the ones that have a bit later afternoon moment. We also have somebody from Slovenia and Belgium. Okay, France, of course, as well. Okay. Super. So we have very different contexts and very different localities. And so this will be great for our next discussions. Very cool. And what would describe you better as a stakeholder type? So even if you're maybe here representing a project, so you can say I'm from the project, but maybe you can say also I'm an NGO or civil society representative, or I'm a water utility representative, etc. So let's see what comes to you. First, after you put your answers, we'll share the results. So we have some of you already voted. We're waiting others to give us their sign. We'll wait for a few more seconds. Now it's half of you. This is an easy question. If it's more than one, just pick one that it's more of your hat right now. If you have more hats, that's okay, we understand. But now let's try to pick one. Okay. Let's see what we got. Oh, so we have lots of researchers today and scientists. And then we have almost equal water utility operators. And then we have also technology providers and engineers. We have somebody from municipality, local authorities, and then we also have some NGO and policymaker. Very cool. Okay. And if we would have these digital decision support tools in your day-to-day water climate work, how this interaction would look like. Is this something you use a lot, so use daily, then it's on the right, or if you are maybe just heard of them, but you haven't really explored them yet, then maybe your answer is more to the left. So try to organize yourself. If you're more to the left, I've mostly heard about them, so I don't really use them that much. Or if you're more to the right, I use them daily. Or maybe you're in the middle, you use them occasionally, and that's also okay. Let's see. We're almost counting. Okay. A few more seconds. Okay, thank you. Okay. Well, let's see where we are. We're somewhere in the middle. If we could guess better middle, I think that we couldn't reach it. So this is an explanation that we are not using them daily, but we use them on strategically or operationally when it's needed. Perfect. And final but not the least question for warm up. What digital decision support tools for climate adaptation or even water system do you already know? So something that you may came in hand with, like maybe something you developed, maybe something you learned about, maybe something you explored or you want to explore. It's also fine you haven't used them, but you know about them. That's also okay. So feel free to share anything that comes to your mind. Okay. Somebody said none. Okay. Or maybe this is X from the X Twitter. Different of digital platform. Okay. Yeah, definitely. WaterSense somehow builds on the run of digital AI-assisted platform for informed decision making for stormwater runoff. Then we have also SimSite's digital platform, School, Invest, dimensioning calculators, or the Runoff platform. Okay. Okay. I give you a couple more seconds if something else comes to your mind. If it comes later, it's okay as well. You can share with us in the chat or in here in Mentimeter. Somebody mentioned also geoportals and weather iOS. This is great. Some new things coming in. And listen, we will be using Mentimeter throughout the whole session. So please don't close it. Keep the tab open or keep it on your phones. This is going to be handy for later, okay? Great. And we also have another one, which is Sims platform. So we have some platforms here. We have 5-6 platforms that are cool. If you have links, you can also share them with us. So this is also a way to do a bit of benchmarking. Otherwise, we're going to search for them. So thank you so much for this. I'm coming back to our presentation. And yeah, keep the Mentimeter open. And now, before we enter to the presentations, we want you to think about what has been said by our speakers. And if something resonates with you, feel free to share it with us in the chat. It can be a comment, it can be a question that we can address later. If it's for a specific project, you can put this question is for one of the projects. If it's general, keep it like that. All are welcome. Okay. Great. Right now, we're going to hear a short overview of each project, specifically how they are approaching the topic of building or developing digital support tools for their specific missions and within their specific contexts. We will have around 6 minutes for each of the speaker. First with us will be Maximiliano Portos Foster from CETAQUA. He will represent CARDIMED. So Maximiliano, the floor is yours. So let me know when you're ready. I'm ready.
Thank you, Olga. I'm ready too. I hope everyone is listening to me well. Hello, everyone.
Yes.
Nice
Perfect.
to have you here. I can start whenever you are ready.
Okay, let's go.
Okay, so I'm gonna go quickly over the digital tool that has been in development from CETAQUA. We call it NBS Exploitation and Transferability Support Module. I know it's a mouthful, but before going to the next slide, I'm gonna briefly mention what CARDIMED is about. CARDIMED stands for the phrase that you see there, Climate Adaptation and Resilience Demonstrated in the Mediterranean Region. It's an innovation project under the Horizon Europe program. Its main goal is the research into systemic transformations to strive for climate resilience in this Mediterranean region. The project looks to unify initiatives to address climate adaptation through nature-based solutions. So if you go to the next slide, please, Olga. I'm going to try to be as brief as possible here. The purpose of this specific tool that we, as I mentioned, have been developing is to facilitate the making decision process and to provide some sort of support to stakeholders into the process of identification, planning, and implementation of these nature-based solutions. From here on, I'm going to say NBS. In order to face the certain challenges that each stakeholder may be struggling with in the context of climate resilience. So basically it helps bridging knowledge gaps that may exist between different stakeholders regarding the NBS implementation, and also gives some additional support to policy and decision makers in their search for adequate solutions to their locally perceived challenges. So the tool is divided into two modules. The NBS Explorer helps you point towards what NBS are best suited to be implemented against certain challenges. This knowledge base has been built with curated answers provided by experts. And on the other side is the NBS Planner that helps you see the most suitable locations for NBS implementation against these challenges. And it gives you a way of seeing at a catchment level what it looks like. Target users are municipalities or other types of local authorities that are responsible for territory planning and management. Local communities, of course, that want to make a push for NBS solutions, and other stakeholders that also may benefit from nature-based solutions, or the portfolio they may look at, and the potential mitigation measures that help fight these climate change challenges and strive for resilience. If you go to the next slide, please. Thank you. So in summary, the NBS Explorer helps you understand how much more adequate than others certain NBS may be against certain challenges, and how to best address those challenges given your NBS portfolio. And on the other hand, the NBS Planner provides a catchment-wide assessment of which areas to look more closely when considering the implementation of NBS. It also guides the user into the different NBS and challenge categories, and to see how these categories interact between each other, what priorities may appear, and to additionally provide a first approach into the geographic aspects of NBS suitability. And also we hope that the user can apply the guidance given by this tool across any areas that may consider potentially interesting. Hopefully, however, each site-specific conditions may impact. So this, in particular, the NBS planner helps shed light into these aspects. On one side, I'm gonna be very brief here. The methodology overview of the NBS Explorer is there was an expert-based assessment that relates NBS to challenges and assigns scores to identify which ones are more adequate to address certain challenges. There was an expert panel consultation to build this set of scores. They were processed using a methodology called the Delphi method. I think it's widely used. And we use this kind of format with spider plots to show the results. In here you can see that we have 3 NBS, and they're pointing towards which challenges they're better suited. But we also show the other way around. You can pick up to 3 challenges, and they point towards which NBS are better suited to address them. And on the other hand, the methodology overview of the NBS planner, there was an intention to build an automatic cartography of NBS suitability that involves geographic information systems, which are usually called layers. So we have gathered layers of information that we then process using this fancy named method, which is called analytic hierarchy process, as part of a multi-criteria decision analysis. And the idea is that the outcome of this is a set of weights that define how much more any other variable is better suited to characterize certain NBS and challenges. So there's 2 kind of processes that we do. There's primary processes where we have to process raw data to bring them to a minimal type of use. But then there's also secondary processes depending on what we're doing with the characterization of challenges and NBS, and depending on which we have to do some twitching and recalibrating of some layers. And I know this kind of may look complicated, but it's really more simple than that. And I have a small diagram to show for it. So on one hand, we have a challenge that we need to address. We try to characterize the intensity of the challenge in the location that we're looking at to see where in that location is more intense. And on the other hand, we have NBS also characterized by layers. And we also, in the map, try to show where is the most feasibility to that NBS. And then we just overlap those 2. And then when you have crossovers or of most feasibility with most intensity of the challenge, you have these heat maps. If you click next, then you have these heat maps of results. Again, at a catchment level, you can still zoom in a lot, but this is how we are approaching this tool. And to wrap up, that will be it. I hope I didn't overstay my time.
Thanks so much, Max. This was great introduction to CARDIMED and your 2 tools. Thank you very much again.
No problem.
And we will continue with our following speaker. So we have Thomas Papas from AQUAMON. Thomas, the floor is yours. Let me know when you're ready.
Yes, hello everyone. My name is Thomas. I'm going to show you briefly the AQUAMON project, which is Advanced Quality Monitoring System of Water in Urban Areas. So if you can get to the next slide, please. I'll like to start with some numbers. don't go through everything at the here. The most important part that I want to focus is, first of all, we started 1 year ago, more or less. So we've had some steady progress, though it's a 4-year progress, 4-year project. And we're across 16 European partners. And the important part that I want to keep for now is that we have 5 pilot use cases. So we're going to try our tools into 5 distinct pilot locations. And that's how we will test our tools. So if you can move to the next slide. This diagram here, thank you, presents more or less the idea of the project. So we install sensors and we deploy robotic devices where we collect sensor data and images or through surface vehicles, information about bathymetry and everything. Then we put it into AI-driven tools to make data analysis and knowledge extraction, to then inform the experts and the end users to further improve the monitoring of the water systems. If you can move on to the next slide. Now, our decision support system can actually be broken down on the different tools that we use to make those decisions. So as you can see in this diagram, we have a mission planner, a Swim AI model, QCRA, QMRA, which I'm going to explain what it is, multimodal fusion engine, and electronic identifiers. All those are different tools that are integrated into a single AQUAMON decision support system, which is then visualized and interacted with through a monitoring dashboard. So if you could go to the next slide, I'd like to very briefly explain a bit those different tools. So the mission planner, as the name suggests, is an application that will generate executable paths for area surveys and point inspections. It will show what is realistically can be reached, covered, and measured at the pilot site. Then Swim AI is an AI model which supports open or closed decisions for bathing sites, mainly by forecasting E. coli risk, and showing, depending on EU thresholds, whether it's safe or not. It can also turn, it actually does that by almost near real-time decision support by combining rainfall, river flow, and E. coli data to predict water quality. The uncertainty part of it, and this goes to all the tools, is also quantified and communicated. We also have the quantitative microbial and chemical risk assessment, which, as again the name suggests, quantifies microbiological and chemical risks for water from water reuse as probabilistic outputs. Again, the objective is to help decide whether mitigation measures are needed and which uncertainties are the ones that matter. It does so by estimating human health risks for pathogen and chemical risks from relevant substances. Could you go to the next slide, please? The multimodal fusion engine now, what it does, it integrates heterogeneous environmental data, sensors, UAV or USV information, laboratory analysis, weather services, etc. And it provides real-time monitoring, early warnings, and predictive insights for water systems. It supports operational decision-making through anomaly detection, early warnings, and short to medium-term forecasts tailored to each pilot needs. Finally, we have the optronic identifiers, which is an AI-powered perception module. So it identifies infrastructure and water quality indicators from visual and multispectral imagery acquired by optronic sensors. The use case that we're using it is one to detect the rotating clarifier bridge in a water treatment plan, and the sedimentation tanks, so that we will now allow other UAVs to acknowledge the area and be able to perform safe autonomous sludge level measurements. They are aware of the objects and they can move around the infrastructure and collect, and this way they can collect all the needed information. It can also identify visual evidence on pollutants, so we can send the drone on a river or another location and will identify like stagnant foam formations or increased turbidity. So this will support rapid assessment of water quality degradation. If you can move on to the next one. So as you see, we have basically AI models bringing up. Now this topic, this will be brought up again afterwards, but basically the core systems like the models, computer vision, data workflows, API pipelines are all universal across all sites, but site-specific information like sensor data or regional variables, robotic capabilities per location needs to be adjusted. And if you can move to the next one, I would like to show you some visuals from these tools. This is a visual of the Swim AI information on how you can select areas and plot data. And if you can move on to the next one, this would be a visualization of the risk assessment by QMRA, where you put the input and you can get a statistical analysis and of the predictions. And the next one, please. And so those are the individual tools. The AQUAMON project aims to integrate all of them into a single platform. So this is the dashboard. This is a very early version, I need to say. So we're not yet, we've not yet progressed there. But the idea is that all these tools would communicate with this dashboard for the end users to interact with it. And I think that's all, barely over time. So thank you very much.
Thank you so much, Thomas. Very good to hear also some similarities and differences in comparison to the previous presentation by CARDIMED. And without further ado, we will go now to Carolina Cantrigiani from Tecnalia for NBRACER project. Carolina, can you hear us?
Yes, I can hear you. Can you hear me?
Yes, perfect.
Good.
So when you're ready, we start the timer and the floor is yours.
Okay, thank you for the invitation. And I'm glad that Maximiliano presented before me because CARDIMED project, it's a sister project for NBRACER. So the goal is the same, but not for Mediterranean regions, but for Atlantic regions. So I'm kind of jumping the first part. I'm Carolina Cantrigiani from Tecnalia. We are in Bilbao, north of Spain. And in this project, we are focused, and our goal is focused on monitoring. So what I'm presenting, you can go to the next. Yes, these are well, I have 5 demonstration regions and 3 replicating regions. These are the ones involved in our project. And it's on demonstrating replicating regions on the Atlantic, as I mentioned, and focus on climate resilience through NBS, the implementation of NBS. And as I mentioned, we are focused on monitoring. That's what I'm showing here. It's not a tool as such, it's a guide that is already available, but the project is working with other tools such as a decision support system for adaptation pathways, or suitability analysis for NBN implementation based on ecosystem services, or a lesson learned tool that we are developing to filter and learn about the experience of the regions in different fields related to the project. I'm not presenting the other ones. Maybe in the future opportunities we can share it, but I'm sure that when they are available, ready, they will be available in the web page and in the social media. So I'm presenting you the monitoring journey guide that is developed as a framework in this project. And indeed, it is meant not to support the embracing regions, but beyond all the regions beyond the project. So it's we try to use very easy language, a very clear sequence of steps, so that any region that would like to go to this exercise of defining their monitoring strategy and their monitoring plan for their MBS could use it. So the next one. And also the guide is included in this cycle of the adaptation pathways and the part of the implementation of NBS, and mainly focus on learning what is the effectiveness of the solution proposed, so that we can include the adaptive monitoring and reflect on the results and be able to replicate and upscale and go back to the planning of future NBS again with better information. So this is the idea, and it is based on a compilation of practice of experience that we have and on robust references. So just to mention that this is not the only existing methodology, but it's a compilation of the key methodology for you to go through this. And for each of the steps, this is a tool formed by 8 steps. Each of the steps, we have developed it in a way that we have clear objectives. We have a main text with description and how the actions can be developed and some practical examples, and a success list for each region that wants to check what they have, what they don't have, so they can reflect what is missing if they want to go through them. Yes, the next one. This is the list of the 8 steps that we have. The manual is very visual and hopefully very easy to understand. If you use it, we would love to receive your feedback. And if you go, if you go to the next, what I'm doing is just reading the title of each step. Then we have some brief descriptions in the bottom, but just for you to know what is it about. And we are working with this with embracing regions, just going step by step, and it can be implemented by any region. So the first one is establishing a monitoring team. The second one, understanding the baseline. Third step is on establishing a vision for the NBS impact. Next. Fourth is selecting the MES to be implemented. Step 5 is defining the set of KPIs, is the one that we are working more. That is one of the goals of NBRACER with the regions. The 6th, the pre-implementation monitoring, all the setting of these KPIs and how they will be monitored. Next one. In between the 6th and the 7th, in theory, it would be where the NBS would be constructed. This project sometimes doesn't work like this, but step 7 then would be the post-implementation monitoring. And the step 8, that is the goal of the monitoring journey, is the impact assessment evaluated according to the monitoring that we got it. So the next one.
Sure.
So just keep the key messages from these guidance, that the impact assessment is super important so that we can strengthen this adaptive planning and use the evidence that we got first to confirm if our NBS is achieving the goal for what it was meant to be built, and then to be included in this cycle of planning and inform the planning and be able to upscale and replicate the positive and successful solutions and maximize the impact, at the same time increasing the resilience to climate change. And the idea is to be a long-term reference document intending to remain relevant after the NBRACER is finalized. So I don't know if it was included in the chat. This document is already available, so feel free to use it and to give us feedback if you use it and find it useful. And even if you have criticism, we are happy to hear them. So thanks, that's it from my side.
Thank you so much, Carolina. This is a very good overview. The monitoring tool. Thank you. And we will now go to final but not the least, a presentation from our colleague from ITG, Jesus Fernandez Aguila. So if you allow me, let me put the timer again and let me know when you're ready.
Yeah, I'm ready. Yeah, thanks, Olga. As Olga said, I am Jesus Fernandez from the Technological Center ITG, that is, we are in A Coruña, in Spain. And today we're going to introduce the digital approach that we are developing in WATERSENS. But first, we're going to talk a little about the project. WATERSENS is a Horizon project that brings together 16 partners from Europe and also from South Africa. And all of us are coordinated by University of Cantabria. The overall objective of the WATERSENS project is to demonstrate the benefits of decentralized water management solutions and to develop a framework that try to assist decision makers and also water professionals to implement this type of solutions. WATERSENS started in September 2025, and for the reason some of the developments are in current the same phase as the decision support system. In this slide, you can see that the WATERSENS is divided in 5 phases. Right now, we are working in the optimization of a innovative solution of the centralized water management. But more than that, we are validating the technologies and try to evaluate the behavior related to the water quality and analyze the impacts. In parallel, we are developing governance models and digital tools as the DSS to try to assist to stakeholders and end users to implement the centralized water management solutions. And finally, the idea is to promote the implementation of this type of solution. Next slide, please. We have 6 demonstration sites, 5 of them in Europe, in Greece, Spain, and Portugal, and 1 in South Africa. And we are trying to validate or implement 6 different technologies that you can see in this slide. These are floating treatment wetlands, biofilters, photobioelectrochemical system, green walls, green rules, and collection cisterns. We have not a lot of time, but I recommend you visit the website of the project to know a little more about WATERSENS. And next slide, please, Olga. And we're going to comment a little the decision support system, that is one of the key outputs of the project. In WATERSENS, we're going to develop a decision support system to support decision makers and water professionals in selecting, implementing, and also evaluating the operational of the centralized water management solution. The idea is to maintain in a same system different types of data, for example, environmental data, economical data, governance, and the project right now, or the decision support system, is in a design phases. We are not provide pictures or indicate how it works, but we can think an approach of the idea that we have for the system. The architecture of the system is divided in 2 main components. One is the technical parts, that we have 3 main layers. This means one part that we collect the data that the system requires to operate from the demonstration sites. Then we have a calculation engine in which we try to process all this information and provide the results, and an additional layer related with the cybersecurity to try to evaluate and investigate, for example, data corruption of this type of new problem that could have the decision support system. And then we have the functional components. In one part, there are the components that we require to operate, for example, bring the data from the sensor to the platform, and other functionalities that are provide or try to help to the decision makers to take decisions related to the decentralized water management solution. I indicate here we are in the same phase and we have not completed, but we have 6 main blocks of the functionalities that we're going to produce. Next slide, Olga. And here you can see these 6 main blocks. One is decentralized solutions, KPIs, in which we're going to analyze how the system works and try to assist to the user in a same platform. We can visualize the operation of the decentralized solution and try to promote this part. Then we have other block of functionalities related to the risk assessments in which we evaluate the environmental, social, technical, and health domains. Also, we're going to apply artificial intelligence and also develop non-artificial intelligence models to try to evaluate the performance of the decision support, the decentralized water management solution, and also compare different approaches. Also, we're going to integrate different tools as a catalog of the solution, a multi-criteria that the user can perform and evaluate and analyze into the decision support system, help to the user in the digitalization process, and also we have one part that is one of the partners of the WATERSENS that is clean, is developing governance models that we will integrate into the platform. Next slide, Olga. But I say at the beginning, we are starting the same phase. 3 o'clock is try to collect information to these SIG blocks, these big SIG blocks, define it in more detail and obtain more specific functionalities that are going to introduce into the system. Here, when this is done, and also some of the tools that, for example, University of Cantabria and Coventry University are developing, we're going to integrate in our same system. Then ITG, as a leader of the development, is going to design the final designs and produce the decision support system that then we're going to implement and validate into the decision into the demonstration sites. And the last slide, Olga. And today I cannot show you the DSS, but this is a pictures that the idea that we have about the DSS that we're going to obtain. As you can see, is going to see a GIS web platform in which we're going to integrate all of the developments and the user can access. There's going to be a common framework, and then it's going to have a different workspace in which we're going to incorporate data from the different demonstration. And as remember in this meeting or in this webinar, we're going to adapt the demonstration to the specific site. And thank you very much. Anything else from my side? And you can see here the nice team of WATERSENS in the last meeting in Lucca.
Thank you so much, Jesus. Very good. Okay, so we heard from all 4 projects. You saw that we are in different places in time when we're developing our tools. When we say tools, sometimes we even have like a framework, a platform. Then within this platform, we have modules that are already kind of sub-tools. So we work with different complexity because responding to the climate adaptation, water systems, application of NBS in our pilots and our context, it requires a robust methodology. And you could see that from these projects, definitely we need more tools than just one. And so we just do a quick reminder to put your questions or comments in the chat for the speakers in general or for each of the project. We will come to them very quickly. Before that, we will just do a bit of exchange with 4 projects. So the first question we will ask them to answer will be about thinking of an intervention when from the idea to operation. At which moment does your tool make the biggest difference? So is it at diagnosis of the problem? We heard that some of you are doing this matchmaking between the MBS and the context and the locality. Then maybe this also includes comparing of the options, or maybe it's about choosing where to act. So localization of the place, maybe it's all above, but then also, what do you think about aligning the actors? We understand that sometimes some interventions require, of course, somebody to initiate, but then also it requires having onboarded other actors, local actors, regional actors, and stakeholders within this type of projects, but also other, let's say, more local, regional initiatives. And so what this question is trying to ask is that, are we thinking more about diagnosis, about this comparison and selection, maybe about alignment with some accessibility to the tool so different actors can check different type of information, or maybe when we think about the system as a whole and use it on a day-to-day basis. So I'm just going to stop sharing screen for a moment, if that's okay, so we can see our speakers. And I would invite first Max from CARDIMED to tell us what is his answer to this question.
Thank you, Olga. I think in our case and in this particular digital tool, I would say that our target is more to help in the comparison stage and in the location, setting the locations. Of course, it's a very bird's eye view of the catchment, but it does help to compare how the different NBS solutions that may be considered, how they're addressing the challenges and which ones might be more suitable than others, and also where in the catchments, where in the general area there can be a close-up into any potential implementations.
Thank you, Max. And what about Thomas and AQUAMON?
Yeah, so from the AQUAMON perspective, I think the moments that are most relevant, I think, are diagnosing, and because obviously it's a monitoring system, so it's all about getting the excess E. coli when it happens, so that you can react when needed. So that also connects to aligning the actors, because we have defined in each case which one should be alerted to respond to each problem that arises. So I guess that would be the focus. Obviously, the remaining points remain valid. Like the location is very dependent on which sensor will alert at each point the issue. But I guess the main focus would be to the ones I mentioned before.
Okay, thank you very much. And then we go to Carolina, who will also have something.
Yes, in relation to the guide, since we have 8 steps, we try to cover all stages of the cycle of implementation of NBS and monitoring it. So it's not linear. It's, of course, if we consider all the steps, we should start from the beginning and the planning and the ideation of the NBS implementation. But in this case, we can go straight to step 5, straight to step 7. So it's not, we try to cover all steps, and indeed the first one is defining a regional monitoring team that will be responsible for engaging different actors according to which step they should go through. So this
great.
would be the case of the guidance.
Just because you were also mentioning the tool that you will be developing at the later stages, can you just share with us briefly how this guide will inform or interact with the tool itself, the digital tool?
Indeed, the digital tool, this guidance is specifically on effectiveness of NBS. The digital tool that I mentioned is more on adaptation pathways that is implemented at regional level, related to the NBS portfolio that the regions are discussing. And I confess I'm not very much involved in this tool, but I would invite you to contact, and I can be the contact here, the developers to show this when it's done. But it's a DSS as well for supporting regions to design their adaptation pathways. And of course, the monitoring would go be included in different stages. But what we want mainly is the last step where we have the impact assessment done, and then we include in the planning of the adaptation pathways. This is the idea.
Yeah, definitely. Everything is interconnected. That's why it was good to hear from your side the complementarities. And and how about you, Jesus?
I agree with Carolina that different steps in which, for example, the decision support system can contribute. In the case of WATERSENS, for example, we are focusing the centralized water management solution. And here, from my point of view, the strong opportunity for our DSS is try to assist in the planning and decision making stage. This means when I need to solve a problem or I need to install a water solution, okay, the platform or the decision, the DSS, is going to help to evaluate if some decentralized solution can evaluate or can implement in this place, compare different solutions, and assist in this process. Also, the platform or the DSS is going to help in the taking sensor and in the monitorization. But I think from my point of view, the big approach is at the beginning, is in the planning and evaluating and comparison.
Thank you very much. This was great wrap up. So we understand that the tool itself can follow and track the cycle as a whole, or more specifically go into the specific moment phase of the process and let's say help us navigate this decision making by trying to explore this, as you said earlier, matchmaking between MBS and the catchment area, and understanding better what we can do at which scale. Very good. And I have another question briefly before we go to the Q&As of the audiences. So as your tools are meant for various sites of different configurations, what do you think should stay the same everywhere, and what does each site set up for itself? So what changes, let's say, in your project, but also what we can expect from maybe some of our colleagues today in this audience that have maybe different setup or different projects. So I go to you, Jesus, if that's okay to start with.
Okay, no problem. From my point of view, and also I think I was commenting in the webinar, it's not possible to transfer directly a DSS in one site to another one, but it's possible transfer a common decision support framework. This means the methodology, the architectures, the analytical, the capabilities. And when you have this part, and you want to transfer other sites, you need to incorporate the specific data, the models that you need to develop because the behavior is different in the site. And I think this is two approaches. One is the framework, the decision support framework that you can transfer between replication sites, and other is take the data and the specific site and then to try to the DSS help in a specific site. But I think it's the two approaches I think in WATERSENS we can develop.
Thank you, Jesus. And what about you, Carolina? What are your thoughts on this?
In relation to the guide, that is what we presented, I think it covers, again, a lot of situations, because we can have one regional monitoring team that is responsible for different NBS and can go through the guide, because the guide is not a practical tool of taking this, and this. It's just examples on how we can do it, and then some point with more than one example. So this is not a tool as such. Or we can have one NBS with different goals or different KPIs and different actors involved. Or we have one set of KPIs that is replicated into different NBS, of course, considering different the singularities of each of them. But yes, it's in this case it's multiple in all sense. I believe.
Thank you. And here we go to Thomas.
Yeah, so I mentioned it as well before, but I can say it again that we have a lot of models. So the architecture, the core system architecture are the same and can be reused across any website. So that would include model parameters, computer vision, API pipelines, but still, even the AI models sometimes need to be adjusted. So, for example, even the imagery, if as different location, you could have an AI model that has been trained on a lot of images and can predict very well. But if a specific website has more special, say, pollution types, then it's always good to adjust to the location. So refine and fine tune the models to the site specific parameters, and that would be the original like the location, how it's the topology of the location, even depending on the different locations, you might have different sensors or robotics available. So you need to adjust maybe the mission planner and the images you get to be sure that you're aligned on the location you're examining.
Okay, yes, definitely. Just had a pop-up for some questions from the audiences, which is great. Thank you, Thomas. So far we're listening. What about the framework can stay the same, and what about models and data and other things needs to be, let's say, always updated as per site. And how would you complement what has been said so far? Max, give us your thoughts.
Well, I think some of the some has already been said. In our case, also the methodology behind the tool remains the same. And in the case of the NBS Explorer, that helps you understand how to relate certain NBS to certain challenges. That won't change if the location does, although the challenges that people may be facing are implicit in the location. So if you change the location, there might be a different set of challenges that might be prioritized. And on the other side, and in the case of the other module, if you want to analyze different locations, you have to adjust the layers or all the set of variables and information to the specific location that you want to evaluate. So that is very much dependent on the site.
Excellent. Okay, thank you, Max. I think we cover this a bit, this introductory warm-up exchanges, so we give also some food for thought to our listeners, audiences. At this moment, we have a few questions. Nicole, did we select some of them, or shall we just go ahead?
There are some questions from Jorge. How much time do we have for questions? How many?
We can address a few questions, yes.
So the
Please go
first
ahead.
question would be, what is your diagnosis of the European water sector regarding digitalization? What are the main barriers for your digital tools?
Okay, so what is the diagnosis of the European water sector regarding digitalization, and what are the main barriers for digital tools is a second question, but it's okay. Would somebody like from the speakers to address, to share their point of view on the diagnosis of the European water sector regarding digitalization? Are we digitalized sufficiently? What is the trend? Anybody would like to share their point of view on this? Is it an easy question, or let's give it a bit of a thought? I mean, to your own experience, we cannot claim for everyone. But from your work and daily experience, do you think that water sector is digitalized sufficiently, or we still have a way to go? What do you think?
If I may say something, I'm not expert on water areas, and I'm not working on this. I'm working on urban sector. But I think when talk about digitalization and mainly at the European level, our conclusions are always the same. We miss resolution from the data available. We miss budgets to be able to produce this data, supporting to develop it. And some important point here is standardization. I'm not sure how it is in the water sector, but this is from my experience on urban sector.
Okay. Well, definitely some things probably match your realities. Jesus, do you have any thought about this, being that you work in the water sector?
Yeah, I think for one side there is the data. We need more data to produce better models, and this is something that we need to work together, and probably we need have common repositories to transfer and try to evolve this part. And also other part, I think, is evaluating transferability. This means maybe combine different types of data in some point. And I think the idea is to evolve in this position. And the most important is have enough data, for example, to apply artificial intelligence properly and develop systems that are strong enough to help the stakeholders and end users to use the DSS.
Okay. Yeah. Thank you, Jesus. And what about these barriers to developing digital tools? What do you think, Thomas or Max? I don't know if one of you could share a bit your thoughts.
I can add a few things, even though just want to mention that I'm also not a water expert, more on the engineer side, but I can second very much what the previous speaker said. For example, the data has been a big issue for us as well to find quality and enough data to train our models. So this is definitely a big challenge. And there was also something, sorry. a minute. It was apologies.
Don't worry.
I wanted to mention something about. So we have a lot of trouble with the budget. Sorry, that was the one that I think Carolina mentioned. That we find out that many people that even though there exists some solutions like sensors or vehicles or other means of monitoring, which is what we're investigating, many of the water plant locations don't have the budget or the knowledge actually to implement them. And so, for example, in our project, many of the participants have big need of such equipment, and it's not easy to acquire.
Is this the only type of data you see missing, the one that we can collect with proper equipment, or is there any other type of data that we are missing that may come from, let's say, having a better access or having more updated databases from different providers? Let's say
it can be from very different providers. And for example, it can be weather information that could be publicly available. And if the weather institution, for example, doesn't provide them, it's a big gap. Also, it could be information that could be gathered from citizens. Now, I'm getting this idea because in London, they actually do have a community where people go outside and collect this information, and we're very happy to have that. But we don't have that in general. This is a very special case, and this is very valuable information. But it could be laboratory analysis from previous investigations. It could be all sorts of different data, so it's not just monitoring. I can give you more examples if you want, but it's definitely a lot of different information that can be useful.
Super. I think this is a good start, and I would also like to come to you, Max, because I saw one question regarding the differences between Mediterranean, so CARDIMED, and Atlantic NBRACER approach to climate change adaptation. As sister projects, have you had a chance to discuss this a bit? What is your understanding about these differences? So I don't know, Max and Carolina. Yeah.
That is a very interesting question. I am not very familiar with NBRACER, but so I don't know how to answer that without the help of Carolina, of course. But and I would say in the case of CARDIMED, we have been addressing climate change adaptation mostly. In this case, it's mostly through the application of nature-based solutions. CARDIMED is it's nature-based solutions that are the main focal point of CARDIMED. So not to be repetitive, but the angle on nature-based solutions is very strong. And of course, it's a very wide concept. So there are many types of nature-based solutions that can target different challenges related to climate change adaptation. So I can give you examples of, I don't know, there are classics. The heat waves, for example, that are going across Europe now, can be addressed through urban planning, on urban implementation of vegetated pergolas or well-based green facades or other green or canopy structure that can help mitigate this accumulation of heat in different areas of a city, for example. So that's or also in coastal regions where there's ever so higher tides or the water level is rising. There are other nature-based solutions that consist of mitigation of waves or the impact of storms, such as mangroves. This type of plant that grows
All
in the
right.
coasts. So things like that. I
Okay.
that would be my take.
Okay. It makes sense. Carolina, yes, please go ahead.
Yes,
Yeah.
just to complement what Maximiliano told us, the basis and the approach of climate change adaptation should be the same because they are all mission projects, and we are based on this framework developed by Pathways to Resilience project that created this resilience, regional resilience maturity model that is followed by all mission projects. And just to share that we are part of a network, I would say, that is called NBS for You, that gets together the 7 sister projects. So besides CARDIMED and NBRACER, we also have Arcadia, also have Natalie, DECIRMED, Land for Climate, and Mount Resilience. These 7 projects usually work in tandem to develop and discuss things together. And of course, the climate change adaptation is very broad. And in our project, the focus is, as Maximiliano said, is on NBS. So it's one of the adaptation measure, one very strong and very key adaptation measure. But the question here is the main difference shouldn't be any difference on the approach of the climate change because of this context.
Perfect. That was a very good explanation and clarification on the approach, and definitely a very interesting point of view. And this final reference that you mentioned, definitely we can check it and share it afterwards. I think we have time for one final question. So Nicole, would you like to read it out?
Yes.
I think it's in the chat. Yeah.
So for projects like AQUAMON and WATERSENS that combine AI models with spatial GIS data within DSS, how hard is to standardize this multi-layer architecture so it can be truly plug and play for new municipalities?
I don't know.
I can start if you
Don't be
like.
scared by the length of the question and the complexity. We know it's not easy to
I
answer
can read
but
it again.
No.
Yeah.
If I may, it's
yes, please go ahead.
No, when something is more on the engineer side, it's easier for me, so it's all good. One thing I want to say though is that standardizing it doesn't necessarily mean that it can be plug and play for new actors. We do standardize our data. Actually, in our data lake, in our central repository, we do have an explicit interoperability layer, which will transform all the information gathered into a standard. Though there are quite a few standards, there's not one. So we will be standardizing them. And if that helps new municipalities or anyone wishing to integrate, then this should be quite straightforward. Though from my experience, at least, it's not necessarily the case because people use different data structures, and in practice, even if we do have a standard way, which helps, we probably need still on the integration process to do some adjusting. But to give a simple answer, yes, we do standardize our AI models with the GIS data. I can tell you the standards that we're thinking about using. We haven't finalized one, but they're quite open and well-known standards that exist.
Thank you so much, Thomas. This was very, very good technical explanation and easy to understand for non-expert. Jesus, would you like to complement with anything?
I fully agree with Thomas referring to the standardization. The problem from my point of view is, okay, I have my models here, is working. They use several inputs. When you have the transfer or the replication, the question is, I have the same data, I have the same input, I can get this data to my system work. I think this is the most difficult, you have the data because in different places you have different data, and then get the AI model that works with some of the parts of the data is complex. You need to refine, you need to retrain. And this is the key, to have the the same data in different places that you can use, that then your methodology works. No, I think this is the tricky question. But for the standardization, I think Thomas is playing perfect.
Okay, very good. So we had a brief moment to clarify some aspects that the audience has raised. Thank you very much for your questions. They were very straightforward, easy or not so easy to answer, but easy to understand and go to the point. And also from the side of the speakers and representatives of projects, thank you again for effort to clarify a bit more, to help us visualize from your standpoint how actually the tools will look like, what are their needs to become effective, and of course finalized in due time. And of course we have started now conversation between these projects, and for sure we will have even more to learn as time goes by. Let me share my screen again for this second part of the session. So now we are going to look a bit into the tool co-design process in WATERSENS, and just briefly gather some feedback also from everyone here present today. And so very quick introduction, how WATERSENS co-design of DSS tool functionalities looks like. So this is a task within the work package that was already presented by colleague Jesus, and ideally we use this process of stakeholder workshops like the one of today in a bit different format than usual, to work with different stakeholders to gather feedback and also understand a bit better how we can inform co-design from bottom-up approach. As you can see on shared screen, we have different methods used to work on this process. We started this already 6 months ago, almost. We're now in month 12, and we're going to finish this task, which is kind of introduction to the process, by month 15, which will be, in this case, November of this year. So we created a process where we started with internal alignment. We went and published a stakeholder survey, for which we also need your help to gather different geographical input, also considering you come also from countries and places that are not only represented in the WATERSENS pilots, demo sites. We do have stakeholder workshops. So we started with internal one with our 6 demos and partners involved in co-design. We went to the local authorities. We work with them in one session, then water utilities, scientists, and tech providers. We were earlier in Lucca, as you could see in one of the pictures, and today we are here on the aspect of transferability and scalability. When we finish these exchanges and this rich input from this process and from the survey, we'll be again doing the internal alignment to make sure that the bottom up and top down, let's say, comprehension of input with all our ideas, ambition, and needs fits also the project's purpose, and also matches the technical and other type of feasibilities. And so just very briefly, we have some highlights to share. So from the side of local authorities, they told us that decisions are only actionable if we have more of the evidence and explainability. So also looked into side of having this decision tree, visualized decision tree, so it's easier for them to make informed decision, which was already kind of mentioned from different projects today when we heard about this matchmaking, planner tools, and even monitoring tools, etc. Utilities, on the other hand, they showed us that for decentralized sites, they have less data than expected. Again, something that was mentioned, so that digitalization has to come first, which was already pointed out quite well. Tech providers and scientists ranked functions by maturity versus value, and flagged also the relevance of societal acceptance. In Lucca, just before we were here. We were in Lucca last month. We placed everything on this matrix that you have on your right. That was about readiness versus usefulness grid, to see what should go first, what is wanted but not ready, maybe something parked for later, or something that's very easy to add on. And so we played a bit with some barriers in functionalities development, or even access criteria, thinking about who should access it at which step, etc. And all this kind of piled up. And besides our 10 functionalities that we already kind of programmed with our blocks in the project, we actually came out right now with 10 new functionalities that came directly from these workshops, and are pointed out as do this first or wanted, and some of them even were parked because they require a bit more thinking. You could see here that the two that came from Lucca were about water scarcity map. We understand water issue is not only about having something abundant and floods, but also the scarcity is an issue, and also pollutant monitoring, which is also interesting. And something that came out through this workshop to point out was that the tool to truly support this decision making, it needs, of course, shared goals, political and also other at the level of the local scale. Then it, of course, and local scale usually is also influenced by other micro scale. But then also what we saw before, that we really definitely require not only internal collaboration between different units, but also external. So the cross-institutional collaboration, and this data access and having more data rights, ensuring possibilities across pilots, but also with replication sites in future is essential. So this is in a nutshell where we are and how this process looked like. So you see we were quite busy for the past months, and thanks to our participants like you, we got a chance to get very, very rich input. So maybe if you still have open your Mentimeters, we can just do a brief check from your side when it comes to the next question. Let me just see if my Mentimeter is still working here. Yeah. Okay. So if you can come back through the link in the chat, or through scanning of this QR code again, that's great. And we were just wondering, okay, you heard what we need and where are we in the project, and what are our, let's say, needs and directions, but what about you? So if you would to use any of these tools that we introduced briefly today, and also now presenting the WATERSENS and everything, what would be what would you need genuinely to make it useful in your city or your organization? So if you can give us some food for thought, that would be lovely. Feel free to share anything that comes to your mind at this moment. So if we think of WATERSENS, we think about water systems or wastewater systems, but also climate adaptation. And of course, yeah, you have different experiences. We saw you know some of the tools. Maybe you haven't used the tool yet, but maybe you can still share with us what would be genuinely needed for you to share it. Okay. So we have one comment about the input and the digitalization, something about user experience, of course, that we cannot ever forget. Having the meat, this engineering part well done, but not having the easy user experience or enhanced user experience can be barrier to applications. So definitely easy to use is interesting answer, and also solid to support decisions. So having the rich evidence or database to analyze from. Use the framework to validate existing tools. Okay. Yeah, this is also an interesting one. And any information should be transparent or traceable in order to be of real value. Okay, particularly when using AI. Definitely, we see the projects are more and more using AI-assisted platform. AI is part of our everyday reality, so we understand the catch or, the possibilities of working with it. There is one also about the interface to connect, incorporate data and functions from other existing tools. So I would assume this is more about like not reinventing maybe the wheel, but trying to kind of complement and gather already existing tools and modules. This tool would be useful in my city organization if it's an easy one to use, provides accurate and up-to-date information, so real-time check, and helps people find services or complete tasks quickly. So on the side of efficacy. Okay. I'll give you a moment for any other thoughts. Okay. And as we are here, we will just ask you, on the sake of transferring these tools to other sites and thinking about data, regulations, infrastructure, or even institutional ownership, what would be the most, let's say, this decision driver? Whether tool would go to other sites. So imagine you have, imagine you use it in your organization or in your town already. What would be objective if you wanted to help somebody else to replicate it in your region, for example, or if you're a regional focus tool, what would be your, let's say, need to share it with another region from the same country or within the context we work in? Any few thoughts, any first words that come to your mind? Would you again look more into data? Would it be something about regulations? Would you still lean on institutional ownership? Okay. Okay, data and regulations, but then also others are important. These are just some examples that we have given. Maybe they are not exhaustive. You can also think about others. Definitely data and infrastructure and regulations are coming in quite often. And there is one that is very genuine. It's about positive previous experiences to be recommended by others. So the word of mouth and recognition of efficacy and effectiveness of a tool also requires a recommendation by a person. Okay, so more data and more standardization. And the proof of the concept of the methodology that it works. Okay. Well, then thank you so much for your feedback. This is very good to hear also how we are thinking through together and also differently. But I think many things are, let's say, overlapping to what has been said today. So thank you once again for your comments. I think before we close, we would like to ask our speakers to just share with us briefly one of their takeaways from today's exchanges with other projects and with our active audiences. So I don't know if somebody would like to go ahead first. Feel free.
Well, I can start by commending the other speakers. It was all very interesting to see. With Carolina, of course, there's a lot of parallelism. There's a lot of similarities. There's a lot of impact assessment going on related to NBS, which I think is incredibly useful, more than deciding how to implement the NBS or how to work with it. I think it's incredibly important as well to understand what are the benefits of it and to try to increase the knowledge on that side. So it was very, very interesting to see that part as well. And in the case with Jesus and Thomas, in the case of Thomas, it was very interesting to see as well, not so much of a water-centered environment of solutions, but more of a holistic, a different kind of view, which was interesting to me. In the case of Jesus, it was more of what I can understand from the water side. So it was very interesting to see how that kind of framework can be put together to address kind of similar challenges that I've been working with.
Thank you so much, Max. It's great to hear that even if we work of slightly different angles of this big picture, that still some approaches and these holistic approaches and frameworks actually can be useful or inspiring one for the other. Having said this, and then I would go to Thomas, if that's okay.
Yeah, I was actually already ready to
Speak up.
to speak up, yeah, because I agree a lot with what Maximiliano mentioned, and it's always interesting to see other perspectives. I think for us, the main takeaway would be the overall concept of transferability, if I may. Because I think we realized maybe while working on this that when you're working on a project, you have the 5 pilot use cases and you focus on those specific 5 pilot use cases. So hearing about other kind of gets you in the process of thinking, oh, so which part of this technology can be used as is and which can't. So all this discussion, I think, helps us kind of like think about AQUAMON in a bigger picture, and all the services as well. So that's definitely a takeaway.
Thank you so much, Thomas.
Thank you very much for that.
And Carolina?
Yeah, from the personal side, I think all these learnings is very valuable, mainly when most of them are so far from my area of expertise. So it's very, very nice to know and to increase knowledge in some points. And from the practical way, I think it's very good as well that we don't work like standalone development of tools. There are thousands of tools around, so that this event finds the synergies and alignment. And I really heard some things here that I think, oh, this could be useful to communicate, to tell this and this person from my project. It may be interesting. So I think this is my main takeaway from this.
Super. This was also one of the reasons why we decided to do this final stakeholder workshop in this way, to open it a bit and have a bit more, let's say, collective intelligence in place. So we're happy to hear that. And final but not the least, Jesus.
Thanks, Olga. I agree with Carolina that the know different aspects and also understand more about the projects that there are in different stages. You know, for example, in our case, we are in the design, but in our case, for example, Carolina presents the guidance, that is very useful for us. In the same phase, okay, see the guidance, see can help. And for example, in other projects, I'm very happy that find that in other projects they have the same problem that we have when we develop the decision support system. You know, especially to implement in other places. You know, as Thomas indicated, we have this problem, and I think we need to go further, work together, and try to solve this problem. How we create a system that with the same data or similar data can work. No? I think this is the things that I take away, and I think it's very useful to comment in between everyone.
And the data struggle.
Yes, definitely.
So
Lots of data struggle.
reassuring. Thank you.
Thank you, Thomas. Thank you, Jesus. Very cool. Now, before we go, we have two final things. One is the family photo. It's our tradition to take a photo all together, which in this digital world means screenshots. So my colleague will enable your cameras and mics in case you want to show and appear in this photo. I will stop sharing in a moment, and so we can see each other better. Very cool. Whoever wants to be on this photo, which we'll of course publish on LinkedIn and social media, feel free to jump in. If you don't wish to be if you don't wish to appear on this photo, you can keep your camera off, no problem. I think we have two screens, perfect. So we need to do a couple of screenshots. Very cool. Look at these faces. Very nice. So give us a smile, a big smile, and let's say maybe data. Just for the sake of fun. Okay, and another one. Give us a big smile. Thank you. Perfect. I took two screenshots. Nicole, are we good? Yeah? Okay. Perfect. So just to conclude, of course, we will share this recording materials of the webinar with you. We're happy to know you find it useful. Before we go, we have, as earlier presented, the stakeholder survey. It's something that we are using to collect a wider geographic territory information, let's say also outside of WATERSENS pilots and our partners. Therefore, it's really cool if we can count on you in filling it out and also, of course, disseminating it. It would be great if you can give us a helping hand, and this will also help us get a bit more input for this co-design of DSS tool functionalities. Okay, I'm aware of time, so thank you for staying with us for extra 6-7 minutes, and we wish you a very good afternoon or morning or late afternoon, depending where you are, and thank you for staying us until the end. Big thank you to our speakers and projects. Well done, and keep us posted. And thanks to my colleague for all the support and everyone who was here today. We couldn't do it without you. So have a nice day and see you very soon.
Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.
Bye-bye.
Thank you.
Bye.
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 Bye-bye.
I don't know. Yeah, we can go. We can go. Ciao.
Ciao.